So we've been talking about plate movements and earthquakes and why mountains are either increasing in height or decreasing, or why they're moving sideways. We looked at those 6 different mountains: Mount Everest, Mount Mitchell, Mount Araki, Mount Aconcagua, Mount Hotaka, and Mount Naradnaya. We've been looking at those for the unit here. And one thing we haven't talked about so far was volcanoes. So we know with the plate movement, with the foam, we see that the plates can make mountains go up. So where we saw 2 plates hit and they go up, we could get mountains there. We know that there's plate boundaries, and plate boundaries could create mountains or move them. If we had 2 plates side by side, that would make a mountain move sideways, as we saw some of the mountains doing. But we haven't talked about volcanoes, so we got to see if this is a possibility. We can't just say we found the answers and move on. We've got to exhaust the list of possible things that make mountains move or grow. So what do we know about volcanoes? We know that lava comes out of them, that a lot of times volcanoes are mountains. We know that they erupt. Sometimes they don't erupt all the time. Sometimes they go extinct, where they don't erupt anymore. And we weren't sure where they occurred. We know they're all around the world, but we weren't sure if they were just all over or if there's certain places they are. So the first thing we want to do is kind of find out where they are. So we looked at this map here, and the key here at the top says the white triangles are active volcanoes, so probably things like within the last year they've erupted. And then the orange triangles are the ones that have erupted since 1980, so maybe not in the last year, but before that they did. And you can see where they are around here. So there's lots of orange triangles. Sometimes they're in lines, sometimes they're all by themselves. Like 1, 2, 3 here are just kind of by themselves, but then we have a whole line of volcanoes here. And we're trying to figure out what we noticed. So we see that they're not all over the world. Yes, they are all over the world as far as locations, but they're not like every single place. So there seems to be a pattern again. So sometimes they form lines of volcanoes, and then sometimes we do have these volcanoes that are just kind of in the middle of nowhere. So we got a couple things going on there. We then looked at this map and then put it on top of where all the earthquakes are. So this one is, again, the white triangles are active volcanoes, orange is volcanoes that have erupted since 1980, and then the circles are earthquakes that have happened since 1980. And the question here is, what do we notice about where volcanoes are located compared to where earthquakes are? And we found for the most part that volcanoes are found where earthquakes happen. So anytime I see a triangle, almost always there is some earthquakes around. Even the one over here, we've got one little white triangle and there's some red dots behind it. Here's an orange triangle, at least 2 earthquakes near it. So it may not be right on top of an earthquake, but there's definitely earthquakes nearby. So it seems like volcanoes are found where earthquakes are, but earthquakes are not always found where volcanoes are. So it seems like there's a one-way road there where we can have volcanoes near earthquakes. And we weren't sure, if volcanoes cause an earthquake or earthquakes cause volcanoes or what. So we weren't sure what happened here yet. Then we wanted to take a look at a chart. We're trying to find out if volcanoes could possibly change mountains, their height or their location. And we don't have any data, so we're going to collect some data. So we're going to work on this, we're going to fill it in, and I'll post a finished one in Schoology. So we want to look at the 6 mountains we've been looking at. We want to see how they change in location, meaning moving sideways. How are they changing in altitude? Are they getting higher or lower? do each of these mountains have a volcano or an earthquake near it? And then finally, is the change to the mountain, whether it's moving sideways or up and down, caused by volcanoes? Okay, so we're going to take a look at that. We have our sheet here, and we're just using these cards that we used a long time ago with Mount Mitchell and Mount Hataka. So we have all 6 of those. So I'm not going to show you each card. I'm just going to kind of summarize what we found out so it goes a little faster here. So looking at the map, so I'm just going back to this map, here. And we're going to go through the mountains and find out what is nearby. So I will show you the finished graph in a second. I'm just going to kind of use this map here to go through. So I'm looking at Mount Everest, and I see earthquakes near it, but I don't see any volcanoes nearby. So I'm going to mark down a no for a volcano and a yes for an earthquake on our chart. The next one down on our thing is Mount Mitchell. So I'm going to go over here. I see earthquakes. I do not see any triangles. There's no volcanoes. On my chart, the next one down is Mount Araki by New Zealand. And here I do see triangles and circles. So that means there's both volcanoes and earthquakes. Mount Aconcagua, which is in South America. Here is the mountain. I see white triangles. I see orange triangles even closer. And I have red dots, which means there's both earthquakes and volcanoes there. Mount Hataka in Japan. I definitely see triangles, definitely see circles, so that has both near it. And Mount Naradnaya, no volcanoes, some earthquakes, but not right on top. I'm going to put an N with a question mark because I'm not sure how I want to handle this one. Everybody else has like earthquakes right on top of them. This one's near it, but not too close. That's not like 2 miles away. That's maybe 100 miles, maybe even more, maybe 200 miles, 300 miles away. So I wouldn't call that close. Okay, so what I just did was looked at this map, and I filled this chart in accordingly. So when I was saying no's and yeses, so I was looking for volcanoes nearby, so an N is a no. Looking for earthquakes nearby, yes or no. So I just filled that in as I was going through the map. Next thing we want to do is look at are they moving and is the elevation changing? So I'm just going to summarize what we found out from the cards. I don't want to go through cards and show you every single part that had it. For Mount Everest, it is moving 4 centimeters northeast, and it is going up 2 centimeters per year. Mount Mitchell was moving 3 centimeters west, and it was shrinking. It didn't say how fast, so it's just a down arrow. Mount Araki was 7 centimeters to the north, 1 to 2 centimeters upward. Mount Aconcagua was going 3 centimeters to the north, and it said 10 millimeters every 10 years, which means it's 1 millimeter every year, which means it's 0.1 centimeters per year. Mount Hataka, they said on the cards, was 1 centimeter to the southwest, and it was 4 millimeters per year, which is actually 0.4 centimeters upward per year. And finally, Mount Naradnaya was a 2.5 centimeters to the east, and it's neither shrinking nor growing, so we're just going to put a dash there, just to show that we looked it up and we got the information, and it just doesn't have anything for us. So then we wanted to see, does the changes in the mountain, these 2 columns here, so do these changes here have anything to do with volcanoes? Okay, so we look at Mount Everest. We see it moving sideways and going upwards, but no volcanoes around. So obviously it can't be due to a volcano. So we're going to say no volcanoes around or nearby. I look at Mount Mitchell. It is moving. No volcanoes. So I'm not worried about the earthquakes. We're asking about would it be caused by volcanoes. So that's, again, a no. No volcanoes nearby. Mount Iraqi. It's possible. I can't say yes because I don't have any evidence of that. It's just a possibility. Mount Aconcagua, it is changing. There is a volcano. That's possible. Just because we have a volcano nearby doesn't mean it's what's making it grow or move. But it's at least it's an option because there is a volcano nearby. Mount Hitaka, same thing. It's a possibility. And then finally, Mount Narodnaya, no volcano, so it's not even a possibility. So no volcanoes nearby. And then as the last part of the class, we were wondering, like, how would we know if a volcano is making a mountain grow? And so we looked and kind of thought about volcanoes a little bit more. And so if we draw, just like kind of the basic volcano shape where you kind of go up and you got the opening at the top and you come back down. Usually volcanoes, lava comes out. Sometimes it runs out and it goes down the side. So we're thinking if the lava came out, and even if it's kind of splashed all over the place and it came down here, that means this is going to build up, which is going to make it higher. But that's not the mountain itself. So it might make the ground higher. But if the lava came over the top and it cooled off and it formed right here over the top, and it doesn't mean it's just over here, it might be wider. Maybe it might make it taller at the top, which would make a mountain grow. In that case, we would be looking for active volcanoes. Because active volcanoes are the ones that are going to be having the lava come out at the top of it. And if a mountain is growing, if we're looking for mountains that grow, we should be looking for active volcanoes here. So we're going to be hopefully see if we can find some data about that. So that's kind of what we did today. We just wanted to see volcano earthquake data chart. Wanted to fill this in, find out which ones we need to take a closer look at, kind of see what we're looking for. We want to look for active volcanoes because these are the only ones that are going to grow. Things that haven't erupted in hundreds of years are not going to get higher because of volcanoes. They might still get higher, but it's probably going to be due to plate movement or earthquakes instead. And the question here today was, can volcanoes make mountains grow or shift? So we'll pick up in this next class.